All right, so test tomorrow's on 2.5 through 2.7, but it does have some topics from before 2.5, but just like make sure you know how to do synthetic division, make sure you know how to factor and things like that. So I'm going to do kind of one from each section on the review. The answers are posted on Canvas already, so you can check your answers with the answer key. This is due tomorrow, so do it to study. Don't just copy the answers down. So looking at number 1, it gives us the zeros. So we have to make sure we list any additional zeros, write it in factored form, and then FOIL it out. So for 1, what zeros are we missing? Awesome. -1 minus 3i, the conjugate of that one. The complex conjugate. Anything else? Negative square root 2 also has a conjugate pair. So if you have an I or a square root, remember they happen in conjugate pairs. So I'm going to start by writing it in factored form. Remember, it's always x minus the number. So we have x minus -1 minus 3i. And then x minus -1 plus 3i. Then x minus 4. X minus negative square root 2 would be plus square root 2. And x minus square root 2. Remember, we always want to FOIL out the complex conjugates first because we can do our conjugate shortcut. So I'm going to FOIL the first 2 together and the last 2 together first. So with the first 2, before I FOIL it out, I want to simplify it. So I'm going to distribute the negative. So we've got x plus 1 plus 3i and x plus 1 minus 3i. Are these conjugates of each other? Yeah, we've got x plus 1 plus 3i and x plus 1 minus 3i. So we can do our conjugate shortcut. Conjugate shortcut is a squared minus b squared. What's our a? X plus 1 would be our a. So we've got x plus 1 squared minus, what's our b? 3i squared. So x plus 1 squared, we want to write it twice and FOIL it out if you need to. X plus 1 times x plus 1. We've got x squared plus x plus 1. This would be minus 9i squared. And what does I squared change to? -1, so that becomes a plus I, plus 9. Then we can combine our like terms. We've got x squared plus 2x plus 10. All right, so we FOILed out the first 2. Now we can do the same thing for the last 2. If you don't like doing the conjugate shortcut, you can FOIL it. Make sure every term in your first set gets multiplied to every term in your second. If you do it correctly, the i's are going to cancel. You're not going to end up with i's in your answer, so just keep that in mind. The i's will always cancel, and the square roots will always cancel. You'll not end up with a square root in your answer. So for the last 2, I'm going to do my conjugate shortcut, a squared minus b squared. So we've got x squared minus the square root 2 squared. What's square root 2 squared? 2. So square root and squared cancel, so this factors into, or FOILs into, x squared minus 2. And then I still have that x minus 4 in the middle too. So I'll FOIL out the x minus 4 and the x squared minus 2 together, and then I'll multiply it by the x squared plus 2 plus 10. So I'm just going to FOIL these 2 together now. The order that you multiply them doesn't matter. If you want to multiply x minus 4 times the first one, that's fine too, and then multiply that to x squared minus 2. That would work. You'll get the same answer if you do it right. But I'm going to multiply these 2 together, so let's FOIL. We get x cubed minus 2x minus 4x squared plus 8. So now this is going to get multiplied to the first one over here. I'm going to rewrite it in standard form. So we've got x cubed minus 4x squared minus 2x plus 8. Now when we FOIL these together, make sure everything in your first set gets multiplied to everything in the second. This one's going to be long, but it's fine. We can handle it. So x squared times x to the third power would be x to the fifth power. X squared times negative 4x squared would be negative 4x to the fourth power. X squared times negative 2x would be negative 2x cubed. And x squared times 8 would be 8x squared. Then we can move on to 2x. So 2x times x to the third power would be 2x to the fourth. 2x times negative 4x squared would be negative 8x cubed. 2x times negative 2x would be negative 4x squared. And 2x times 8 would be 16x. And then we can move on to 10. 10 times x cubed would be 10x cubed minus 40x squared minus 20x plus 80. Told you it was going to be long. Now let's combine our like terms. So we've got x to the fifth power. I'm going to cross them out as I go just so I don't forget anything. Now x to the fourth power. So I've got negative 4x to the fourth power plus 2x to the fourth power. That would be minus 2x to the fourth power. So I'll cross these out now. Now x cubes. We've got negative 2x cubed minus 8x cubed plus 10x cubed. Negative 2 minus 8 would be negative 10. Plus 10 would be what? 0. So the x cubes just cancel. We don't have an x cubed. Now x squareds. We've got 8x squared minus 4x squared minus 40x squared. So 8 minus 4 would be 4. 4 minus 40 would be negative 36x squared. Then 16x minus 20x would be negative 4x plus 80. That would be our answer. Don't forget, this is a polynomial function, so we're going to write it as f of x equals. So don't forget to name it at the end. On the test, I'll get to your question in 1 second. On the test, you may see something like, this is made up, so these numbers aren't going to work out, but keep this in mind, write it down, practice one of the ones from the WebAssign if you need to, or go back to the notes. Let's say I had something like x squared plus, or x, we'll say x to the fourth power plus 3x squared plus 2x. Sorry, let me change these variables a little bit. So x to the fourth power plus 3x cubed plus 2x squared plus 10x minus 50. Something like this. And it said that one of your zeros is 4i. And it says, find all the zeros. What would we do? How many zeros do we have here total? We're going to have 4. So what do we do to find the other 3 zeros? Do we know of any other ones? If 4i is a 0, what else is going to be a 0? Negative 4i. So we'd want to write this out and find out what a factor would be containing these 2 zeros. So I'd write it in factored form. We've got x minus 4i times x plus 4i, sorry. Minus negative 4i would be plus. These are conjugates, so we can do our conjugate shortcut. That'd be a squared minus b squared. So x squared minus 4i squared. Notice how I write it in parentheses because we have to square the 4 and square the I. So x squared minus 16i squared. What does I squared change to? -1. What's -16 times -1? Plus 16. So x squared plus 16 is a factor. How would I find the remaining factors? What would I do? Bless you. Long division, yes. Again, these numbers are not going to work out because I made them off the top of my head. But we would do long division. We've got x to the 4th power plus 3x cubed plus 2x squared plus 10x minus 50. When you divide, what's our remainder going to be? 0. When you do problems like this and it gives you a factor and you have to find your remaining factors, when you do long division, your remainder is going to be 0. And then you factor the answer. So solve the answer to find the remaining zeros. So whatever you get as your answer, set that equal to 0, solve. You may just have to solve it, or you might have to factor it to find your remaining zeros. So there's nothing like this on the review, but you will see something like this on the test. So go back to the homework, go back to the notes, practice these questions. Again, if you finish working this out, it's not going to work out because I made these numbers up, but practice one from the homework. For 3 and 4, it says write the polynomial as a product of quadratic and linear factors irreducible over the rationals and irreducible over the reals. Find all the zeros. So when it's irreducible over the rationals or over the reals, again, I'd go back and look at the notes just to keep in mind what your answers need to look like. If something was irreducible over the rationals, it can't have square roots or i's in your answer. You'd write your answer in factored form from the step before. If something is irreducible over the reals, you can have square roots, you just can't have i's. Can't have i's. For part C, when it says find all the zeros, just write x equals whatever your x is going to be equal to. So the other two, part A and B, want it left in factored form. So just make sure you understand the difference between irreducible over the rationals and irreducible over the reals. Let's practice number 4. What would we do first to solve here? Awesome. I'm going to take out my GCF. Always, if you have a GCF, take that out first. So I have 0 equals, we're going to divide out 2x. We're left with x to the 4th power minus 5x squared minus 14. Now let's factor this. What are 2 factors of negative 14 that add to negative 5? Awesome. Negative 7 and positive 2. So I've got x squared. Be careful here because we start with x to the 4th power. So when I split this up, it's going to be x squared and x squared. So x squared plus 2 and x squared minus 7. And then 2x out front. Can I factor any of these anymore? Nope. So let's set them equal to 0 and solve. So 2x equals 0, x squared plus 2 equals 0, x squared minus 7 equals 0. So x equals 0. For the next one, I'd subtract 2 on both sides. So x squared equals negative 2. Take the square root. So what would x equal? Plus or minus I square root 2. Awesome. We take out the negative from under the square root, turn it into an I. Don't forget, when you take the square root of both sides, you need plus or minus. For the third one, I'm going to add 7 to both sides. So we get x squared equals 7. Take the square root. What does x equal? plus or minus square root 7. So for my zeros for part C, I've got x equals 0. I'm going to write it separately just so you see all 5 answers, but you can leave it as plus or minus on the test. That's totally fine. So I square root 2, negative I square root 2, square root 7, and negative square root 7. So those were the 5 answers that we were looking for. We had x to the 5th power as our highest degree, so we knew we were going to have 5 answers, so found them all. If I wrote this in factored form, we'd have x times, this would be x plus I square root 2, x minus I square root 2, x plus square root 7, and x minus square root 7. But is this irreducible over the rationals? No. If it's irreducible over the rationals, we can't have what? We can't have i's. What else? Can't have i's or square roots. So we'd have to go back to the factored form before we had i's or square roots. So that would be from here. So we have x. You can leave it as 2x. That would be okay too. But 0 comes from just x. So just x times x squared plus 2 times x squared minus 7. So this is irreducible over the rationals. You can't have square roots. You can't have i's. Irreducible over the reals, we just can't have i's. So we can't have these two. So what was the step before I had x plus I square root 2 and x minus I square root 2? Where did these come from? What was the factor? What was the step before? X squared plus 2. So I'm just going to replace the i's part with the x squared plus 2. So here we have x times x squared plus 2. And then the other ones, the square roots, we can leave in it. Irreducible over the reals, you just can't have i's, so we can leave the square roots. X plus square root 7 and x minus square root 7. And again, this one is complete factorization. Yes. When we write it in factored form, if we take our zeros, it's always x minus the number, so x minus 0 would just be x. So again, you can leave it as 2x, but 2 is just our common factor, so you could divide everything by 2 in the beginning and get rid of it. So either way is fine. If you want to leave it as 2x, that's okay, but 0 comes from just x, so that's why we would just leave it as x. But either way works. Yes. You might. In my opinion, complete factorization is the easiest because you don't even have to think. You just list all your zeros. X minus this zero, x minus this one, x minus this one. The other two, you kind of got to think about it a little bit. So when I first get the test, the first thing I would do is write for irreducible over the rationals, say can't have square root, can't have i's. For irreducible over the reals, can't have i's. I would write that down to begin with, just so that way when I go to write my answer, I can kind of look back and remember, oh, for part A, I can't have a square root in my answer and I can't have an I. For answer B, I can't have i's in my answer. Everything else on the test comes from knowledge of the cheat sheet from 2.6 and 2.7. Make sure you have everything from that cheat sheet in your brain. You cannot use the cheat sheet on the test. You need to have it in your head. So practice, practice, practice. It's a lot of little things on the cheat sheet. You guys, I know you know how to do the math, but it's knowing what goes with what. So just make sure you practice and have all of the things from the cheat sheet in your head. For number 5, we're going to find the domain, vertical and horizontal asymptotes, and the x and y intercepts. So let's start. I'm going to start with the horizontal asymptote. What do we need to look at when we're looking for the horizontal asymptote? The exponents, the degrees of the numerator and the denominator. So the degree of my numerator would be 0 because I don't have any x's. The degree of my denominator is 2. So when the numerator is less, what does that mean? Y equals 0. Awesome. Our horizontal asymptote would be y equals 0. Next, let's find our vertical asymptote. What do we do to find the vertical asymptote? Perfect. Set the denominator equal to 0. How would I solve this? Take out the GCF. I'm going to divide everything by 3. Let's simplify this, make the numbers a little bit easier for us. So we've got x squared plus x minus 6 equals 0. What are 2 factors of 6 that add to 1? 3 and negative 2. So x plus 3 and x minus 2. So what does x equal? Negative 3 and positive 2. So our vertical asymptotes would be x equals negative 3 and x equals 2. Next, for our domain, remember domain and vertical asymptote go hand in hand. We set the denominator not equal to 0 for the domain. So it's going to be the same numbers. How would we write it in interval notation? Negative infinity to negative 3. Negative 3 to 2 and 2 to infinity. Awesome. So it's going to be the same numbers from your vertical asymptote. You just have to write it in interval notation. So make sure you practice this. And then for x-intercepts, remember x-intercepts are the same thing as finding the zeros. On the test, it could say find the zeros, or it could say find the x-intercepts. What would we do here to find the x-intercepts? What does our cheat sheet say to do? Set the numerator equal to 0. So when it says find the zeros or find the x-intercepts, set the numerator equal to 0. Can 1 equal 0? No. So what do you think our x-intercept is? None. We don't have one. We have nothing to solve here. 1 cannot equal 0, so there is none. Lastly, let's find the y-intercept. What do we do to find the y-intercept? Plug in 0 into the x's. So when I do that, I'll do it on the side over here. We've got 1 over 3 times 0 squared plus 3 times 0 minus 18. So zeros would just be 0. So this is 1 over negative 18. This is what my y equals for my y-intercept. How do I write the y-intercept as a point? Zero comma negative 1 over 18. Awesome. We plugged in 0 for x, and I got negative 18 for the y. So x and y intercepts always have to be points. Let's look at number 12. So it says find the slant asymptotes and vertical asymptotes. How do I find the slant asymptotes? What do we need to do? Long division. Awesome. So I'm going to divide x plus 5 into x squared minus 6x plus 7. Now you can do synthetic division, especially for a question like this, but if you had a quadratic function on the bottom where you had x squared that you were dividing into it, and let's say x cubed on top, you can't do synthetic division. So I'll tell you right now, on the test, you cannot do synthetic division. So make sure you know how to do long division. So x squared divided by x would be x. Multiply everything out front, we get x squared plus 5x. What do we do next? Change the signs and combine. X squareds cancel. Negative 6x minus 5x would be negative 11x. Negative 11x divided by x would be negative 11, and multiply that times everything out front. We get negative 11x minus 55. Change the signs and combine. 11x's cancel. 55 plus 7 would be 62. 62 would be our remainder because you can't divide that by x. What do we do with the remainder for our slant asymptote? Throw it away. Get rid of it. So what would our slant asymptote be? Y equals x minus 11. Remember, it's a line. Your slant asymptote is going to be a slanted line. So it's got to be in y equals mx plus b form. Any questions here? Next, it asks for the vertical asymptotes. What do we look for the vertical asymptotes? Set the denominator equal to 0. So we've got x equals negative 5. So our vertical asymptote would be x equals negative 5. 15 has a slant asymptote. We've got time. Let's find it. How would we find a slant asymptote? Long division. So inside the box, I've got x squared plus 4x minus 5. Outside, x plus 1. X squared divided by x would be x. Multiply, we get x squared plus x. Change the signs and combine. 4x minus x would be 3x. 3x divided by x would be 3. Multiply, we get 3x plus 3. Change the signs and combine. What do we do with the remainder? Throw it away. Doesn't even matter. Negative 8, that's our remainder. Doesn't matter. What would my slant asymptote be here? Y equals x plus 3. Awesome. Don't forget the y equals. When I draw this, I know that you guys know how to draw a line. What's our slope? 1. What's our y-intercept? 3. So we start by plotting our y-intercept. I'm going to put a point at 3 on my y-axis. How do I do the slope of 1? Rise over run. So up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. So this would be our slant asymptote. So it's just like graphing a line. For 16, just because we have a minute left, let's look at 16. Let's find the holes. We'll practice finding our holes here. What do we do to find if there's holes or not? How do we find the holes? Factor. We want to factor our numerator, factor the denominator. What are 2 factors of 6 that add to 5? 2 and 3. So this factors into x plus 2 and x plus 3. And on our denominator, how do I factor x squared minus 9? X plus 3, x minus 3. It's the difference of squares. Perfect. Do we have a hole here? Yeah, what cancels? X plus 3. If you have the same factor in your numerator and denominator, they cancel. We've got a hole there. So x plus 3 equals 0. What does our x equal? Negative 3. So the x in my hole is going to be negative 3. How do I find the y? We plug it into the simplified version. So on top, I have x plus 2, and on the bottom, I have x minus 3. So I'm going to plug this in to the simplified version. So we've got negative 3 plus 2 over negative 3 minus 3. So this would be negative 1 over negative 6, which would be 1/6. So what you cross out, set it equal to 0, plug it back into the simplified version to find the whole. So 18, we're going to find everything. Let's find our horizontal asymptote, vertical asymptote, domain, the zeros, the y-intercept, and holes. When you're finding everything here, first thing you want to do is check for holes. How do we check for holes? We'd factor. Can I factor the numerator? No, but can we factor the denominator? What does the denominator factor into? X minus 4 and x plus 4. Awesome, it's the difference of squares. Do we have anything that cancels out with the top and the bottom? No. Perfect. No holes. So if you get something that cancels out, you have a hole at that number, and you'd want to plug it into the simplified version to find the y. Next, let's find our horizontal asymptote. What are we looking for the horizontal asymptote? The exponents. So our exponents on the top and the bottom are the same. What does that mean? We look at the coefficients. So what would our horizontal asymptote be here? Y equals 2. Awesome. Be y equals 2 over 1, which would just be 2. Let's graph that. So I've got a horizontal line through 2. How do we find our vertical asymptote? Set the denominator equal to 0. So when we set it equal to 0, we would factor it to solve. I already factored it in the first step when I was looking for holes, so I can just set this part equal to 0. So what does x equal? 4 and negative 4. Awesome. So x equals 4 and x equals negative 4. So I'm going to put a vertical asymptote through x equals negative 4 and 4. What would our domain be? What is it? We set the denominator not equal to 0. So it's the same as our vertical asymptotes, but how do we put it in interval notation? Negative infinity and negative 4. Negative 4 to 4 and 4 to infinity. Awesome. Perfect. Next, it asks for the zeros. Remember, zeros are the same thing as the x-intercepts. How would we find the x-intercepts? Or the zeros? What do we do? Set the numerator equal to 0. So I've got 2x squared equals 0. So what does x equal? We divide by 2. 0 divided by 2 is 0. So x squared equals 0. Take the square root. What does x equal? What's the square root of 0? 0. So our x-intercept, how would I write that as a coordinate point? 0, 0. So I'm going to plug that in. I have a point at 0, 0. How do we find the y-intercept? Plug in 0 for x. So I've got 2 times 0 squared over 0 squared minus 16. So we get 0 over negative 16. What's 0 over negative 16? What's 0 divided by negative 16? 0. So what would our y-intercept be? 0, 0. Same point. Now let's find where our graph goes. Remember, we have 3 sections here. I'm going to have a part of my graph over here on the left, a part of my graph in the middle, and a part over here on the right. So what would we want to plug in to find how the left side of our graph goes? What can we plug in? Sure, anything that is less than negative 4, because that's where our asymptote is. So you can plug in negative 5, negative 6, anything over there. Let's plug in negative 6. So I have 2 times negative 6 squared over negative 6 squared minus 16. Negative 6 squared, make sure you follow your order of operations here. You've got to square it first. So negative 6 squared would be 36 times 2, 72. Over 6 squared is 36, minus 16 would be 20. When you plug in numbers, you'll get fractions. Just simplify it as much as you can, or make up the nearest whole number. Figure out what the nearest whole number would be. How many times does 20 go into 72? 3 times. With 12 left over, so it'd be 3 and 12 over 20, which would be about like 3.5, right? So this would be, I'll call it 3.5-ish. Remember, when you're plugging in points, it does not need to be exact. Just make sure you know which 2 numbers you're in between. So I plugged in negative 6, and I got 3.5-ish. So am I going to be, when I go to negative 6, am I going to be above the horizontal asymptote or below? Above. Our horizontal asymptote was at 2, and 3.5-ish is above. So I'm going to go to the left to negative 6 and up 3.5-ish. So now that I know I'm above my horizontal asymptote, I can draw my graph in this quadrant that I have here, this kind of corner. It's going to hug the corner, and as my graph goes out to infinity, my arrow is going to get close together. So my arrow is going to get close to this one. Your arrows are going to be close to each other. So our graph looks like this. Remember, your asymptote to your graph is going to get really, really close, but it's not going to cross that line. It's not going to touch. Your graph's going to get really, really close, but it's not going to touch. So if I had a graph that looked like this, would this be a correct drawing of my graph? No, remember your asymptotes are going to get, or your line's going to get close to the asymptote. So that would not work. Now let's figure out the middle. What's a good number to plug in the middle? Sure, we can plug in 1 and negative 1 and see what our graph does in the middle. So let's plug in 1. You could say 2 and negative 2, 3 and negative 3, anything in between negative 4 and positive 4. So let's plug in 1. We've got 2 times 1 squared over 1 squared minus 16. So this would be 2 over 1 squared would be 1 minus 16, so negative 15. So this would be, it's negative and it's less than 1, right? So it's going to be in between 0 and negative 1. So we plugged in 1. I'll call it, you could call it negative 0.2-ish or negative 0.1-ish, something like that. It's less than a half, less than. So we go to the right one and down about there. It's negative, so we go below our x-axis. Let's plug in negative 1 to see what the other side of my point at 0 is going to be. We've got 2 times negative 1 squared over negative 1 squared minus 16. So this would be 2 over negative 15. So again, the same point. We've got negative 1, comma, negative 0.2-ish, we can say. So I'm going to go to the left to negative 1 and down about negative 0.2-ish. Then this gives me an idea that my graph's kind of going to be a parabola at the bottom. So I'm going to make sure my asymptotes end up really close together. So our graph looks like this. It's not always going to be a parabola in the middle, so make sure you plug in something in between. If you have a point at 0, in between 0 and your vertical asymptote here, and in between 0 and your vertical asymptote in the negative direction. So I would recommend just plugging in the same number and the negative. So we plugged in 1 and negative 1. Now let's find out what the right side of our graph is going to do. What's a good number to plug in on the right side? 5 or 6, either one works. We can plug in 5, sure. Let's plug in 5. We've got 2 times 5 squared over 5 squared minus 16. 5 squared is 25 times 2 would be 50. Over 5 squared is 25 minus 16 would be 9. How many times does 9 go into 50? 5-ish. We can say 5 goes into 5 with 5 left over, so about 5.5-ish. Remember, when you plug in numbers, it does not have to be exact. Just make sure you're close to the number the whole number. Be close to the whole number. So we plugged in 5 and got 5.5-ish. So I'm going to go to my graph. I'm going to go to the right 5 and up 5.5. Is that going to be above my horizontal asymptote or below? Above. Be right there. So we know my graph's going to be above my horizontal asymptote. I can draw. It's going to hug the corner there. And as it goes out to infinity, it's going to get really, really close, but not touch. So this would be our graph. Kind of notice the difference between the left side and the right. It's really just how I graphed it. If I were to plug in 6, I probably would have gotten the same number, which was like 3.3-ish is what we said, or 3.5-ish, so it would have been there. So my graph on this side's not like super duper accurate, but I'm looking just for the shape. I'm looking for where you are, where your arrows are going, and that's really it. Just make sure you hug the corner and your arrows are getting close to your asymptotes. Let's say our slant asymptote, I think the page before has